Today we're going to discuss the counting principle. Basically, it's the way to calculate the number of outcomes in a probability problem. Simply put, what you're looking for is a way to determine how many possible outcomes you can have given a particular situation. In order to figure that out, you simply multiply the events together to get the total number of outcomes. So if you have two events going on, then you just simply multiply them together. Take, for example, the sandwich shop. How many possible sandwiches could you make if at your sandwich shop you had three types of bread, white, wheat, and rye, one type of meat, four types of meat, ham, turkey, chicken, and tuna, and then 5 toppings, mayo, mustard, ketchup, tomato, and lettuce. If you wanted to determine how many possible sandwiches could be made at that particular sandwich shop, all you would simply do is take the number of potential choices that you have for bread, which are 3, and then multiply it times the total number of potential meats that you have, or possible meats, which is 4, and then multiply that times the total number of toppings that you have. You see, when you're determining your outcomes, there's 3 possible breads that you could choose from, 4 possible meats, and then 5 possible toppings. And so multiplying those all together, you're going to end up with 12 times 5, which is 60. Anyone who's ever stood in line at a store where they sell sub sandwiches and you have someone to pick their bread and meat and toppings understands the amount of time that you can spend waiting for people to make decisions. In this particular case, there's 60 possible outcomes that you could have. So again, to determine the total number of outcomes, all you need to do is to multiply together the possible outcomes from each independent event. Another example that a lot of people like to talk about is the lottery. For example, the Pick 3 lottery. How could we determine the total number of outcomes for the Pick 3 lottery? Well, each jar contains 10 numbers, 0 to 9. So the numbers 0 to 9 are in the first jar, the numbers 0 to 9 are in the second jar, and the numbers 0 to 9 are in the third jar. Each one of these jars are independent of each other. They're going to draw one number out of the first jar, one number out of the second jar, and one number out of the third jar, and that will determine the winner. So basically, there's 10 possible numbers that can be picked in the first jar, 10 possible numbers that can be picked in the second jar, and 10 possible numbers that could be picked in the third jar. Multiplying each possible outcome together, you end up with 1,000 possible outcomes. So the odds, for example, of you winning the Pick 3 lottery is 1 out of 1,000. As we continue our discussion, we start to look at not only possible outcomes, but the ways that we can determine those outcomes. For example, does order matter? Back up to the Pick 3, there are different bets that people can make determining whether they're wanting to the actual order of the numbers, or it doesn't matter about the order of the numbers. You can win money that way as well. But when you look at determining the outcomes, that will not change. There's 1,000 possible outcomes, or 1,000 possible arrangements of the Pick 3 numbers. But let's just take a little closer look. In problem number 3, we're asked, how many ways can the letters in the word cat be arranged? Arranged means ordered, and that's going to become very important in just a minute. So we're asked, how many ways can the letters in the word cat be arranged? Well, let's just take a look at that pretty simply here. If I keep the first letter C, I can take the A and the T and place it. That's one arrangement. But if I take the T and the A and switch it around, well, that's another possible arrangement. What if I start with the first letter of A? Then I have the C and the T left over. If I start with the letter A, I can rearrange the T and the C, and that would be another arrangement of the letters in the word cat. What if I start with the T? Then I have the A and the C left over, or T and the C and the A left over. Now there are no other arrangements in the word cat that can be possible. So if I count them up, 1, 2, 3, 4, 5, 6, the answer to the question is there are 6 possible arrangements of the letters in the word cat. Now the reason why there were 6 is because ordered mattered. When I rearranged the letters, that counted as a possible outcome. So every single time I rearranged the letters, that became a possible arrangement or a possible outcome that I had to consider. And so if I take a look at the word cat a little bit closer, no matter which letter I pick first, whether it's the C, the A, or the T, let's say I chose T first. Well, I take that out. So you see the very first time that I picked a letter, I had 3 possible letters to choose from. Now, as you can see, I only have 2. So let's say I take the A next. Cross that out. So I have to write that 2 in because I had 2 possible outcomes or 2 possible letters to choose from. Now very easily there's just 1 left. The only thing left is C. So as you can see, whenever I make my choice of which number I want to go first, I then would eliminate that and I would be left with lower possible numbers to choose from or lower possible outcomes to choose from. Because of this happening, order is what has created this problem. You see, if I didn't eliminate that T, in essence, if I picked it and then stuck it back, then what would end up happening is I would not have ended up with 6 possible outcomes. So the question becomes, do we allow repetition or do we allow letters to repeat? So let's take a look a little bit further. Sorry about moving things around. How many ways can the letters in the word door be arranged? Well, again, very quickly, there are 4 letters in the word door. So no matter which one I pick first, D, O, O, or R, my first choice is going to be 4. So let's say that I did pick the D first. Okay. Now I have 2 letters, 2 O's that are left, and an R. Now this is where the interesting part comes in. How do we know which O has been picked? For example, if I pick an O, we had 3 left to pick. What we end up with is another O to pick from. Well, let's say I didn't pick that O. Instead, I picked an R. There were 2 left to pick. Okay, so let me go back through this now. The first letter I picked was D. Cross that out. Then I picked one of the O's. Cross that out. Then I picked the R. Cross that out. And as you can see, there's just 1 left over. However, we don't know which O was picked. Whenever you end up with the opportunity for repetition, what we have to do is divide that repetition out. So since there were 2 possible O's, we're going to simply divide by 2. So how many ways can the letters in the word door be arranged? Would simply be 4 times 3, which is 12, times 2, which is 24, divided by 2, which is 12. Again, we had to divide by 2 because there were 2 O's. If there were more than 2, then we would have to divide by how many O's we had. Take a look at number 5. How many ways can the letters in the word cabbage be arranged? Well, as you can see, there's 1, 2, 3, 4, 5, 6 letters, 7 letters in the word cabbage. So depending on which one I choose first, I could rearrange. But to speed up this process, we know that we would pick 7 first, and then after that, there'd be 6 letters left, and then we'd pick we'd pick 1 out of the 6, and then 1 out of the 5, and then 1 out of the 4, and then 1 out of the 3, and then 1 out of the 2, and then 1 out of the 1. That would account for every possible letter in the word cabbage. However, we now know that we have to divide out the letters that are repeating. You see there's 2 A's, so we're going to divide by 2, and there's 2 B's, and we're going to divide by another 2. If there had been 3 B's, we'd have multiplied by 3 in the denominator. And so now to calculate what we have here, using your calculator, you can just simply type in 7 times 6 times 5 times 4 times 3 times 2 times 1. And you end up with 5,040, all divided by 4, which is 1,260 possible ways that the letters in the word cabbage could be rearranged. Again, we're focusing on outcomes. I know you may be sitting there wondering, why do I want to figure out how many ways that the letters in the word cabbage could be arranged? Because you're looking at outcomes. Whenever you're determining probability or the chance that something can happen, you have to know all the possible outcomes that could exist before you can make that determination. One last example is the word house. Notice that none of the letters repeat in the word house. So if I had to choose how these letters could be arranged, I would start with, let's say, the U. So there were 5 letters to choose from when I picked the U. And now, as you can see, there's 4. So I'm going to choose the O. So I use the U and then the O. And now the S. And now the E. Whoops, that should be a 2. Sorry about that. And then now the H. Now that word doesn't make any sense. That's not the point here. The point is that we were choosing certain letters, and so that we come up with a different arrangement for the letters in the word house. The correct possible outcomes that we could have is 120. So there's 120 different ways that the letters in the word house could be arranged. Whenever you are multiplying in a descending order, you're basically just talking about a factorial. Now, believe it or not, that looks like an exclamation point, and your eyes are not deceiving you. That's exactly what it is. So when you see 5 with an exclamation point next to it, this means 5 factorial. It means you start with the number 5 and you multiply by descending numbers until you get to 1, which is 120. So 5 factorial is 120. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Again, you start with your 6, well, go all the way down to the number 1. And 6 factorial has a value of 720. Now again, where would this come from? Again, if you are picking or choosing, arranging numbers or letters, then as you can see, this looks very similar to what just happened a few minutes ago with the letters in the word house. So we come up with a whole new way of multiplying based on something called a factorial. And again, that means to do what? To start with whatever number we have and multiply in descending order. Take a look at number 9. Here we have an example where this 4 is being multiplied by 3 factorial. So this would become 4 times 3 times 2 times 1. As you can see, I did not include that 4. I'm going to now go ahead and find out what 3 times 2 times 1 is, which is 6. And so I'm going to end up with 24. Now some could argue that that's the exact same thing you would have got if you would have taken 4 factorial. But I use that as an example because what if I'd have had 5 times 3 factorial? Well, that would have been 5 times 3 times 2 times 1, which is 5 times 6, which is 30. So you have to pay attention to how things are written. What about dividing with factorials? Well, 8 factorial, if I expanded it, 8, 7, 6, 5, 4, 3, 2, 1, all over 5 factorial, 5, 4, 3, 2, 1. As you can see, if I just take the 5 in both the numerator and denominator, I can reduce, and I'm simply left with 8 times 7 times 6 as my answer, which is 336. Now there is a couple of things you need to keep in mind. 0 factorial is equal to 1, and of course 1 factorial is also equal to 1. I hope this helps with your understanding of how to calculate possible outcomes given different types of situations.